you over the last two pages because there's really just two questions here. Basically, question 9 has you take a scenario and you're going to compare. Jack and Jill decide to keep a tally of the number of text messages they receive each day. The number of messages received by Jack on a day N is given by this equation. So, you can put Jack in either one. If this is, let's say, I'll put him over on this far side. Say this is Jack's equation, and his is M equals 3N. Okay? The number of messages received by Jill on day N, where N is the number of days, is this one. I'm going to call this Jill. And that one is the graph. It says it's shown in the graph below. So this picture here is actually Jill's picture. So you could put dots on the lines to maybe see a couple points at least. Find out whose number of daily messages is increasing more rapidly. So we're just going to start at 0 and plug some numbers in. So if you do 3 to the 0 power, because it says 3 to the n power, that's 1. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 3 times 3 times 3. It's 27. Let's keep going here. This is where I get to need a calculator. That's 81. 243. Okay, those are all Jill's numbers. Now we're going to do Jack. We're going to have the same numbers to plug in. Just always start them at 0. If you do this, this would be 3 times 0 is 0. 3 times 1 is 3. I'm just literally replacing the n in that problem with this number over here. So 3 times 2. 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Okay. So you're going to be given points for filling out the table to compare Jack and Jill's information. Find out whose number of daily messages increased more rapidly over time. Use data to support your answer. So you can make a table, you can show me graphs, but if you look at these numbers, at 1 they have the same, but then looking at these, see, at 2, Jill's already up to 9. By 3, Jill's at 27 and Jack's at 9. So clearly it looks to me that these numbers are getting bigger faster. So Jill increases faster. So you not only have to show me some information in the data by putting these tables, plugging in numbers, writing some numbers down, you also have to tell me your choice. Who do you think grew faster? You can't just show me data and not pick or choose which one you think is bigger. So Jill's was definitely growing bigger than Jack's, so Jill's increasing faster. Alright, and then we have what's called the performance event. All our tests have a performance event at the end. This is more applying it. This is the very front of your test has this formula on it, and it's also written right on your test when you need to use it. So you're given a gift of $3,000 bond for the year you were born. The value of the bond increases at 3.5% per year. Write an exponential growth equation. So just a reminder, this is how much money you start with. R stands for rate. T stands for time. You want to take your rate that's given as a percent and change it to a decimal. Otherwise your numbers will get crazy big really fast. So we start, and you can put y equals if you want, but we start off with $3,000, and we need to change this rate of 3.5% into 0.035. You move it 2 decimal places. Okay, we also would like to see you not only plug in the numbers, but simplify, which means you're going to take 1 plus that, it just gives you 1.035. It's just a little cleaner, so when you go to type the numbers in your calculator, this is what you're going to be typing in your calculator when you plug in T for time. So now we're going to create a table, so this is technically the answer we're looking for. Changing that rate of 3.5% to the decimal 0.035 because we moved it 2 decimal places. So, create a table that represents the money you will have after 5 years. Again, I started at 0, but by the time I got to 5, it fit in the table. Then, graph the table and label the axis. So, if you plug this in your calculator, it would look something like this. 1.035, you're going to put to the 0 power, because these are T, this is your time, so everywhere you see that little exponent, you're going to put in this number. So I'll show you just how to enter that into a calculator. We would type 3,000. And then I would put my parenthesis, 1.035, close my parenthesis. The exponent button is over here on the left. You can see my fingernail down here. To the exponent of 0. Okay? When you plug in 0, you get 3,000. That means at 0, ground 0, the first initial amount you have is $3,000. Now, if you have an arrow key, you can go up and change that. If you don't, you just type it in again. And this time you're going to put in 1. After 1 year, we'll have $3,105. Exponent this year at year 2 will be up to 3,213, and I'll just put we'll put 0.68. I guess we're talking money, so I'd kind of like to round to the nearest cent, unless it says round to the nearest dollar. After year 3, we'll be at $3,326.15. $3,442.57. Year 5, $3,563.06. Alright, so that was a whole lot of plugging in your calculator, filling out a table, but it's very important to be able to write the equations so you know what to put in your table. Remember, in a T-chart, this is your X column, this is your Y column. So we're going to put time on the bottom. And I just spaced it out just to give myself a little bit more room to see. Totally up to you if you want to do that. You don't have to. We want to have value or money going up the side. Since 3,000 is my smallest number, I'm going to put a break in the graph and start here at 3,000. And I only have to go to 3,500. So, let's see, if I do 100, skip 1, 200, skip 1, 300, skip 1, 400, skip 1, 500. Okay, so I'll be able to fit it in if I go by 50. So I'm going to do this one as 3,100. Skip 1, 3,200, 3,300, 400, 500, 3,600. So I was still able to fit it in there. So basically every line is 50. So 3,000, 3,050, 3,100, 3,150, 3,200. But it just allows it to see it a little easier. So at 1, we have 3,105. Well, that's probably just a little bit above 3,100. and we have 213. Well, that's 250 and that's 200. It's probably not even halfway, okay? Then at 3, I have 3,326, 3,442, 3,563. So this is 550. So 563 is going to be a little bit above that. And that in general is kind of, you're just estimating on the graph the best you can. You get points for putting labels, you get points for picking out scale numbers, and then of course plotting your points. Predict the amount of money you will have on your 10th birthday. So right now we went up to 5. And you could continue to 10, but that would be a lot of numbers. So on your 10th birthday, we're going to replace the T for time with 10. Figure out how much you would have on your 10th birthday. By your 10th birthday, that would be 10 years, you would have $4,231.80. So all revolves around being able to write this initial equation. So this number up front is how much money you start with, or how much money you put in, how much something's worth. It grows at a rate. The percent needs to be changed to the decimal by moving it 2 places. And then T just represents the time that you're going to plug in.